Okay, let's go over number 1 and 2. We have 885 degrees. That's a really large angle. That just indicates that that it's rotated multiple times, more than once around your circle. So I'm just going to subtract 360 once. It didn't quite get there, so I subtract 360 again. Ultimately, I'm going to subtract 720, which is 360 twice, and I'm able to make my way down to an angle measure that I can recognize between 0 and 360, so 165. Okay. I said 720, but you can just do 360 twice, and that'll get you there. But if the angle is way too large, where you don't want to spend the time to keep on adding 360, 5, 10, 15 times, then just take your large angle divided by 360, get an idea as to how many rotations it's going to go, and then take that round to the closest whole number, multiply by 360, and then you can subtract that large number from a multiple of 360, and then that'll get you down to an angle measure that will speed up the process. Number 2, negative 435. So I did negative 435 plus 360. It didn't quite get me there, so I added 360 again, and then it got me to 285. So this is in the second quadrant. That's in the fourth quadrant. All right, try 3 and 4. If you don't recognize your radian measure because it's larger or outside the range of 0 to 2 pi, then you can keep adding 2 pi or subtracting 2 pi until you recognize that fraction to be between 0 and 2 pi. So here's 3 and 4. So 17 pi over 6. If you just look at that fraction, 17 over 6, that is larger than 2. So we know we have to kind of scale it back into something that we can recognize. So I can subtract 2 pi. I'm just doing it without a calculator, so I just found common denominator. So if you use your calculator, just do 17 over 6 minus 2. That'll get you down to a measure that's between 0 and 2 pi. Yes?
Can you just convert back to degrees and then convert your answer back to radian?
That's true. Yeah, you can. As long as you can present your answer in the same unit as the starting, you can do everything in terms of degrees and then bring it back in terms of radians. Okay. Number 4, same idea. Negative pi over 4 is outside my interval, so I'm going to add 2 pi to get it to something that I can recognize. So that's 7 over 4. 7 over 4 is between 0 and 2. So that's a coterminal angle that we can keep. Okay. I do want to point something out here, is that many of you guys are feeling more comfortable to be able to just convert it to be a degree measure and then working from the perspective of degrees, which is perfectly fine. But I just want to point out that it's not too difficult to do it in terms of radians as well. And I want to kind of talk a little bit about just looking at the fractions and understanding how that's going to work. So we know what degrees look like in terms of the quadrants, right? This is 0 or 360. If it's 360, that means we're rotated around. This is 90, that's 180, that's 270, right? So in terms of radians, we know that this is either 0 or 2 pi. Okay. We know that 90 degrees is pi over 2. Think of it as 1/2 pi or pi over 2. 180 is pi. And then 270 is 1.5 pi or 3 over 2 pi. Okay. Now, don't worry about the pi. Just look at, I want you to just look at the fraction or the number in front of the pi. This is either 0 or 2, right? This is 0.5. 1/2 is 0.5. This is 1. And 3 over 2 is 1.5. So for instance, if you didn't know where 7 over pi landed, you can just look at that fraction. 7 over 4. 7 over 4, if you convert it to a decimal value, you can hit that fraction FD button there. 1.75. Okay. If you think about 1.75, 1.75 is between 1.5 and 2, so therefore must be in the fourth quadrant. Okay. So I think sometimes you're looking at your radian measure and that pi is really throwing you off. Just look at the fraction in front, right? If you can think about that fraction and you can use a decimal to get a decimal, you can use your calculator to get a decimal approximation, you're going to know where that decimal is going to land, right? And if you know where that decimal lands, then you know what quadrant it's going to be in. Of course, if you want to continue to convert back in terms of degrees, that's fine. But down the road, we're going to have to be more efficient with our radian knowledge. Okay, it's just not going to be worth our time to keep going back to degrees. Okay, but I want to start at least having you consider working in terms of radians. But for now, you can, degrees is fine. Yes.
If we convert it to degrees, do we need to convert it back to radians for our answer?
If the problem is presented to you in terms of radians, you have to give me your answer in terms of radians. Okay. If
the answers for 5 to 80.
Yeah, so let me go through those. So 3 and 4, are we okay? Okay,
Yeah.
so number 5 through 8, asking for a positive and negative coterminal angle. Some of these, I think for 7, I produced more than 2 negatives. So, but as long as you have a positive and a negative, then I just chose the closest one to my starting value. But you can always add more multiples of 360, and those will be sufficient as well.
Is that negative 9 pi over 2?
Yeah, that's negative 9 pi over 2. But you only have to produce one negative and one positive.
On number 7, they both ended up being negative. That doesn't matter.
Well, this started off as negative. I added 2 pi. It still wasn't enough to get me to a positive. So I added another 2 pi, and finally it got me to a positive.
Oh, so you have to.
Right. So if you did not, if one iteration didn't get you to change your sign, then you got to add another 2 pi. So Any other questions 5 through 8? Okay, if you're done with 5 through 8, I'll leave this up for a second, go to 9 and 10. 9 and 10 is asking, are the angles coterminal? So we want to know, are these angles going to line up with each other? So what I do normally is I take the angle that is further away, and I'm going to either subtract or add 360 or 2 pi and see if that will eventually get me to match with one of the other angle that's presented. Okay. If I can either add or subtract 360 or 2 pi to my larger, the one that's further away, if I can get it down to the other angle, then I know that they're coterminal. But if I add or subtract 2 pi or 360 and I can't get the two to match, then they're not coterminal angles. Okay. Anybody still need 5 through 8? We good here?
Would this be called non-coterminal?
Oh, you just say that the angles are not coterminal. You can just say no. I just said no.
Did this show you work, or if you do it on a calculator?
The calculation can be in a calculator, but just show me that you're adding and subtracting 2 pi or 360 just so I know how you arrived at your answer. But you don't have to show me every calculation. Just show me how you are approaching the problem and that you understand the process. So for 9, I'm going to work with that 475 because that's the one that I don't recognize. So if I subtract 360, if I can get that 475 to eventually turn into 115, then I know that those share the same terminal sides. 5 pi over 6, I know that is going to be in the second quadrant. 23 pi over 6, I'm not so sure. So I'm going to keep subtracting 2 pi and see if it will turn into 5 over 6 pi, but it never does. If I subtract 2 pi, I get 11 pi over 6. If I subtract 2 pi again, it takes me to a negative 5 over 6. It completely skips over 5 pi over 6. They're not the same coterminal angles. Yes. Yes. So eventually, if they're coterminal angles, we should be able to either add or subtract 360 or 2 pi and eventually make our way to the other angle.
So I can just leave it like that, like I don't have to use that.
That's right, yeah.
Okay.
Just start with the one you don't recognize and see if you can get it to the one that you do recognize. And just get them to match up. That's all you need to do. You don't have to do 115 and get it to match 475. Just do it from one measure.
Can I call my mom? Got it right.
All right, any questions, 9 or 10? All right, let's go to page 25. Yes.
Is the P pi?
Yeah, P in the here is means pi, but I'll make it more clear on the quiz tomorrow. Yes.
Number 10, okay, that I just kept on adding 2 pi to see if it would get to 23 pi.
Yeah, that works too. Yep, that works. As whichever one you want to start with, as long as you can show me that they don't line up or they do line up, that's what I want to see. Okay, reference angles. Reference angles are sometimes require a bit more work involved because we may have to do a couple of things. And what I mean by that is sometimes the angle that's presented to you is not an angle that you recognize, So you need to you may need to do a little bit of work to get a coterminal angle to be recognizable before you work with the x-axis, right? Okay, so again, for instance, for number 11, the idea with reference angle is we want to be able to identify where that angle is. So this one is pretty easy. 100 degrees is going to be in the second quadrant. So if your angle is in the second quadrant, you know that you want to find the angle measure with the closest x-axis. So ultimately, I'm looking for a reference angle that is going to be between 0 and 90. And the only way I can do that is if I subtract 100 from 180. Okay.
You just subtract it by the degrees that it shows.
Subtract by the closest x-axis that you have.
Oh.
So if it's in the second quadrant, you're going to subtract from 180. If it's in the third quadrant, you're going to still subtract using 180. If it's in the fourth quadrant, you're going to subtract using 360. If it's in the first quadrant, then your angle is going to be the same as your reference angle. There's no need to change it. Okay. All right, try number 12, and I want to talk about some of these.
Because it was closer, because it was in the second quadrant, you subtract by 180 and you got it. Okay.
That's right, yeah. Make sure that you're never subtracting with the y-axis. You're only subtracting with 180 on the second and third quadrant, or 360 if it's over on the fourth quadrant. Yes. So this you don't recognize, right? So you got to subtract 2 pi until you get it to between 0 and 2 pi. Okay, so here are the steps you're going to be taking for a lot of these problems. First, look at your angle measure that they give you. Is it in the range of between 0 and 360 or between 0 and 2 pi?
No.
If it's outside those ranges, then you're going to either add or subtract 2 pi or add or subtract 360 until you can recognize that angle, until you can rename it into a coterminal angle that lands in these.
Why? But what happens if it doesn't land in it at all when you subtract or add?
It should. It should, right? I mean, if the angle's too far away, we should always be able to add and subtract until we get it to between 0 and 360 or 0 and 2 pi. Okay, I'll go over. Are you talking about number 12?
Yeah.
Okay. All right. So let me go over the steps here. Now, once you find that angle that lands nicely in the region that that fulfills these conditions, then You can graph it depending, and then put it in the correct quadrant. And then you can determine your reference angle. And now your reference angle, you're targeting between 0 and 90 or between 0 and pi over 2. Okay, so these are the two big steps we're going to kind of follow. Okay, get your coterminal angle between 0 and 360 or 0 and 2 pi. And once you have that, graph it, and then use that information to find your reference angle, which will now be between 0 and 90 or between 0 and pi over 2. Okay, so here is number 12. First thing, 67 pi over 18.
Is P mean pi?
Yeah, P means pi. This is too large, right? If I did 67 over 18, oops. That's 3.7, right? That's more than 2. So I know that I can subtract 2 pi and get it into a fractional value that's between 0 and 2. So when I do that, I get 31 over 18, which is 1.7, which is in that range between 0 and 2.
Oh, I was for some reason thinking something included.
So it doesn't have to be a special angle. As long as that fraction is between 0 and 2 pi, you fulfilled the condition here.
Is that your reference? Is that that's not your reference angle? That's just your.
That's the coterminal angle you're going to use to help you find your reference angle. Okay. So 31 pi over 18. I'm going to rename this over here. If the graph wasn't drawn for you, then look at that fraction value. 1.72 is clearly larger than 1.5 and less than 2, so it must be in the second quadrant. And now, because you're in the fourth quadrant, you're going to be subtracting from 2 pi to help you find that reference angle. And you want a reference angle that will produce an angle that's between 0 and pi over 2.
So I got negative 518 over 18, negative 500.
Okay, so to find the reference angle, you're going to do the larger minus the smaller. So do 2 pi minus. And you should get a positive value every time.
5 over 8.
There you go. And if you're unsure whether that is sufficient, look at that fraction. It should be less than 1/2. 0.27 it is. Right.
So that's your.
That's our reference angle. Okay. So we're always going to be checking with these two conditions. Make your coterminal angle in the range. Graph it, then determine how you're going to get to that reference angle. Okay.
What's the, so because number 14 is in the second quadrant, you wouldn't be adding or subtracting by 2 pi, would you?
That's right, no. 2 pi is only in the fourth quadrant. If it's in the second and third quadrant, you got to deal with 180 degrees, which is pi.
Oh, so you just multiply it by 1?
Or you just say 1 minus 1 over 18. If you don't want to deal with the pi, then just say 1 minus 1, 11 over 18.
Okay.
Question?
I put it in degrees. I didn't.
Got it. Yeah. If you want to do everything in degrees and then do everything in degrees and then push it back in terms of radians, that's fine as well. Okay. Yes. If the graph isn't drawn for you, though, I need to still be able to find that. So keep adding 360.
It's a little bit more.
So you should be able to recognize it.
That's X or something like that.
Not yet, not yet. Say the 180 until you're confirmed that your coterminal angle is in the second or third quadrant.
Okay.
Then you can figure out your reference
If
angle.
it's in
But
the
your first goal is you're going to have to add or subtract 360 so you can recognize your angle. You want to know where that angle is.
Sorry for Why am I doing Isn't that, so for 13, the reason you did 720 is because it went 2 groups around.
Because plus 360 wasn't enough for me to get into my range. So I had another 360.
But it's also 2 groups around, so.
That's right. But once I got this angle to be in the first quadrant, 65 is also my reference angle because it's already between 0 and 90. So I don't have to do anything with it.
So are we doing the same thing for 15 through 20?
Yes. Yeah, they're all the same. Yeah. My reference angle is always going to be the measure between my terminal side. What's the angle?
Oh, yeah, minus 5, yeah.
Right, so here's another rule here.
It shows you that because it's 2 circles.
Your terminal side is.
You don't need to do that. That's what I was confused on, so figured it out.
Yeah. Because here's your goal. Your reference.
Oh, we have to do that.
If your angle is already. Yeah, keep asking questions. Yeah, let me put those up.
Negative 40 would be in the.
Wait, what was the answer for?
Okay, guys, I have 17 through 20 up here.
So negative 40 would be in what, the first quadrant or the fourth quadrant?
Wait, 320?
No, just negative 40 would be.
Negative 40 is going to be the fourth quadrant. Because if I,
Because it's the same as 320. You just subtract 360.
are you talking about?
I'm talking about 17. I subtracted 360. I got negative 40, which would be.
Wait. So once you have your angle measure, always subtract from the larger number. So subtract from 360. 360 minus 320. Subtract the larger minus the smaller. Because your reference angle is always going to be a positive number. Hmm? Yeah, that, I'm going to be doing with you though.
Okay.
Yeah, but I'll check it on Monday probably.
Yeah.
Wait, what's the homework? This
We're doing it in class. You don't have to take it.
Yes.
I'm slow. Very slow. You just speak up.
Yeah. Okay, 14. Negative 25 pi over 18 is not in the interval between 0 and 2 pi. So I'm going to add 2 pi. So I added 2 pi, and I got 11 over 18. 11 over 18 is a fraction that is between 1/2 and 1. So I know that it must be in the second quadrant. So I know I can work with this. So once I know that my angle is in the second quadrant, I know I gotta involve the x-axis, which in this case is pi. So I just do 1 pi minus 11 over 18. 1 minus 11 over 18 is 7 over 18. Make the calculator do the fractional stuff for you. And then this fraction is between 0 and 1/2, or between 0 and 90 degrees. So that's our reference angle. Yes. Okay, 19.
Without converting it to degrees.
Got it. Okay, so 19, I have negative 4 pi over 3. That is not an angle that I want to use because I want to find a coterminal that is between 0 and 2 pi. So I added 2 pi, and I got 2 pi over 3. If you look at that fraction, 2/3, that's 0.6, 0.6 between 0.5 and 1. So I know it's going to be safely in the second quadrant. I know I have to involve the closest x-axis, which is pi. So I do 1 minus 2/3, which is 1/3. So that's mine. So my theta prime is just going to be pi minus 2 pi over 3. So 3 over 3 minus 2 over 3, it's just going to be 1 over 3. That makes sense. Okay. Yeah, if the pi is throwing you off, just look at the fraction and then just think about it in terms of the fraction.
Wait, so this is mine?
Hello?
Wait, so how do you determine the fraction on the graph?
Okay.
So for number 16, I got 1 over 9 pi, but how do you know where that is
Okay,
without turning it back into a
got it.
degree? Because I don't feel like I.
So think of this as 0, okay? Think of this as 1/2 or 0.5, 1 and 1.5. So if we do 1 over 9, 1 over 9 is going to be like 0.1. So 0.1 has to be between 0 and 0.5, so that's between
1/9 is between 1/2 and
So-
0. So okay. So then it's just 1/9 because you don't do any of it.
That's right, you're done. Pi over 9 is between 0 and pi over 2, so don't read your reference angle. Okay, guys, I want to make sure that I can go through each type of problem. So can you guys put this on a separate sheet, or if you can find it, some space on your handout? We'll do an arc length problem. Okay? And then I want to be able to do 1 or 2 of the trig practice problems as well. Okay. Arc length, we need to be able to know how to work with S equals R theta. Okay, arc length, pretty straightforward, but there's one thing we got to be careful about. What is the restriction for this formula? Theta has to be in radians. So if your theta is not in radians, you got to convert it to radians before you can use the formula. Okay. So I know I'm solving for S, I know what formula I'm using, but that theta needs to be adjusted first.
This is the only thing that. So what? Easy? I don't really understand. Want to explain it to me in my terms? Just like baby. We'll switch the phone.
No, we can't.
Is that all you do?
No, that's what I'm doing. I'm just saying, what's the point of avoiding trade-off? It's literally so much.
That's right, yep. And then reduce it, and then plug in the calculator. So it does Here, just enter.
Oh,
Decimal value is fine.
Yeah.
48 pi.
I didn't know I did that.
Oh, you multiply by 5. So you still gotta multiply by 3.1.
You have to multiply by 5?
Yeah.
So this one you do multiply by 5.
Oh, before we didn't because we're just comparing fractions, right?
Yeah.
But here we have to get a decimal value to plug into the calculator.
I see. My Siri and my AirPod just did Now she said she's not sure she understands. Can't see.
Okay, do you guys get that for S for arc length? Okay. What's the unit that we have to use for arc length? Good. It's always matching the same units as radius, right? No degree, no radian.
See, I get a fraction when I. Oh wait, I forgot you can do that.
Yeah, convert to a decimal and then use that. Question?
It will round it there, 0.8.
That's fine. Use that.
No, I got it. I'm still just one.
That's fine. Show me your work.
Oh my God.
Well, mine goes to 1.6755.
Yeah.
All right. Okay, any questions with arc length? You'll see one of these problems on the quiz. Okay, let's shift over to the word problem. Yes.
So you need for that, would it round to 6 or round to 5?
Are you ready for special
Either is fine. You can either keep that third value or you can round it from the fourth.
Is it a maze? I don't get this. The special right triangle.
Okay, so in your handout, let's try number 2 first. Okay. Okay, this is the word problem handout that you guys picked up. So this is going to be the way that you've drawn it from or seen it from the packet that you've been working on.
Is this going to be on the quiz?
Yes, you got one of these here.
So which one are we doing?
Let's do number 2 first.
No, but I didn't know why you were drawing that.
Okay, so it says you're standing on a plateau that's 800 feet above a basin where you see 2 hikers. Angle of depression is 25 degrees and 15 degrees. How far apart are the 2 hikers? So we have to make sure that we put our angle measures in the right place. Your angle measures are always going to be how you would place them as well as angle of elevation.
I think it was the other way around, but it doesn't matter.
Because usually you would see them closer.
So if someone is further away, then your angle of elevation is going to be smaller.
Yeah, you're right.
If you're closer, then you're having to look further up.
Yeah, you're right. I
Um,
forgot you were a math teacher.
so
Oh, I'm sorry.
what I think is helpful is if you draw 2 separate triangles. That way, you're able to find each of the bases separately. Because just like the previous problems that we've done, we're just finding the 2 bases and we're subtracting them. If we subtract them, we can find that difference, and that will tell us the distance between A and B. So here's my large triangle. I named that base Z. My small triangle, I named it Y. So ultimately, if I can just find Z and find Y, if I subtract these 2 lengths, I'm left with that X, which I'm looking for.
It's opposite, so it would be.
So I have my 2 triangles drawn. Are we going to be using sine, cosine, or tangent? Tangent.
What side are you supposed to find? You're finding the
The height is given, the height is 800.
Okay.
That's the,
All you have to figure out is the 15, you don't have to figure out the 24.
so here's my two separate triangles, right?
What, I'm trying to think. Literally.
So I think what I'm gonna do is I'm gonna take this, I'm gonna split it up into two separate triangles.
Yeah, I realize that.
Okay, so can you find, so you wanna find Z and find Y.
Why do you,
Because Z is gonna be this entire length. Y is gonna be this.
this is how far apart are the two?
Exactly, you're
Right.
looking for X.
So if I take this distance, and if I subtract this distance, what am I left with? I'm left with that.
Oh,
So Z is gonna be this
Oh,
entire,
I see.
because I can't just start with this, because I don't have a right triangle here.
That's
So I
what,
have to-
that's
so I-
what I was thinking, you could start with that, but.
Yeah, so I have to use
I
this
realized.
triangle and this triangle, and use that to help me find this weird triangle.
Okay, so. You should don't save even have one. Do you understand how to do this?
Okay, so Z is 2985, Y is 1715. I'm gonna subtract the smaller from the larger. And I got 1270.
On the, it's a quiz, right?
Yeah.
On the quiz, will it tell us what we need to route to, or do we route to?
Yeah, I will specify what to route to. Yeah, because with these problems, they're all separate directions. So yeah, just read the direction and it'll specify in there. Okay. I don't have time to go over all these problems, but I'm hoping that if you feel like you need some additional practice, you can try this at home. The key is on the website, so work through and use the key. But I'll also be available tomorrow morning. Well, tomorrow morning, I'm doing a help session for my calc students because they have a quiz as well.